and this is a new textbook, children. This is a new textbook. See, here we are getting we are starting from exercise 1.1. Actually in the old textbook we had one more, that is exercise 1.1. CBSE included the Euclid's division lemma, okay, EDL, but this time actually last year itself it's deleted, that portion is deleted, but it was in the textbook, right? So this year new edition came without the Euclid's division lemma and the last exercise, right? Can you follow me? Now this exercise 1.1 and this is the new edition, exercise 1.1, and the one more exercise, exercise 1.2. That's all. Two exercises you have to learn, and actually we had 4 exercises, but now this year only 2 exercises you have to learn. Okay. Now first of all, before starting this, I'll tell you what is the real number. Actually we are studying the real numbers here. The chapter name is real numbers, right? Can you tell me what is the real number set? Real numbers, here we are given the first chapter. Actually what is the real number set? Anyone, can you tell me? Anyone please, if you know the answer, please give in the chat box. Please give in the chat box what is the real number. Actually what are the real numbers? Give me the answer, quick. Real numbers. Yeah, I can see you. Yeah, Madan, good evening. Yeah, welcome to my channel, APD Math. Okay. Now children, actually real number set is the set of rational numbers and irrational numbers. Okay, rational numbers and irrational numbers. Actually rational number set, what are the rational number set? You know that rational number set means all the numbers including whole numbers, natural numbers, all numbers, rational numbers. We have learned about rational numbers. Now real numbers means all the combination of the rational and irrational numbers. Okay, combination of rational and irrational number. And last year, that is in 9th standard, we have learned about the many numbers. 9th also we have learned how to represent the irrational number on the number line. Do you remember how we can represent the root 2 on the number line, root 3 on the number line, etc, etc. Many things we have learned first chapter itself in 9th standard, right? 9th standard we have learned many things regarding this rational and irrational numbers, right? How we can say that one number is an irrational number, then 2 types of your decimal expansions and all we have learned from the 9th standard, right? So here we are just studying the continuation, that's all. We are studying little bit more about the irrational number and the rational numbers. Little bit more we are studying in this year 10th standard. Okay. So mainly we can see that in this real numbers we can say that the first one is fundamental theorem of arithmetic. Okay, fundamental theorem of arithmetic. That is what is the fundamental theorem of arithmetic? If you have started this, you will understand that. I'll tell you. Let me take the pen, children. Wait. Okay. So what I said, actually real numbers, let me check. This is nothing. Okay. This I'll get only this pen from here. Okay, next in the open board we'll take another one. Now actually the real numbers are the combination of the irrational number and the rational number. Combination of these two sets are known as the real number set. Okay, combination of the irrational number and rational number and irrational numbers. Okay, now first one you want to learn about the fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? What is actually this fundamental theorem of arithmetic? Actually, this says that all the numbers, that means any composite number can be factorized as a product of primes. That means actually before that I'll start from the composite number and the prime number. Okay, what is the composite number, what is a prime number? Do you remember we have learned from 7th, I think from 4th standard itself we are studying this, right? What is a prime number and what is a composite? Is it 4th standard? Well, our classes we are studying what is a prime number and what is a composite number. Actually, what is a prime number? Can you say that prime numbers are actually 2, 3, 5, 7. Is 9 a prime number? 9 a prime number? No, 9 is not a prime number. Why 9 is not a prime number? You have to explain now. Give me in the chat box. Okay, why 9 is not in the prime number? 7, the next prime number is 11, next one is 13, then 15. Is 15 a prime number? No, 15 is not a prime number. Then next one is 17 and so on. Right, children? So these are the prime number set, right? Prime number set. That means these numbers, if you are taking all these numbers, suppose I am taking 2, okay? 2 you can see only in the table of 2, right? 2 ones are 2. 2 ones are 2. Only we can see this 2 in the table 2, right? We cannot see, that is 2 ones are 2. We cannot see any other table. That means there are actually 2 factors for 2. 2 factors. 1 and the 2, the number itself. 1 and the number itself, right? Same way you can take 3. 3. You take 3. 3 is also a prime number. Why this is a prime number? Because 3 we can write as 3 into 1. Only you can see this 3. 3 in this prime number. That is 3 in the table of 3. You cannot see anywhere, right? That means the factors are 3 and 1. Therefore, there are how many factors? 2 factors are there for 3. Understood? 2 factors are there. That is the 1 and the number itself. So, these type of numbers are known as prime numbers. Okay? Prime numbers. So, 2, 3, the next one 5. You take 5. 5 is also a prime number. Why 5 is a prime number? 5 you can see in 5 table only. Isn't it? There is 2 factors. 5 ones are 5. Okay? This way, if you are getting only 2 factors, 1 and the number itself, we can say that this is a prime number. Okay, this is a prime number. Clear? So 2, 3, 5, 7. Then I asked a question. Did you answer that? Yes. Yes, Jason. It is more than 2 factors. Yeah, you are right. Okay, more than 2 factors. Yeah, correct. Now here it is actually what is that? 6. 6 is not a prime number. You can say 4 is not a prime number. See. 4 is not a prime number. How many factors are there? Actually 4 you can see in many tables. That is 2 table you can see. 4 table also you can find 4, right? So 4 is a composite number. That is what are the factors of 4? We will write here. 2 2s are 4, right? So 1, 2 and 4. See, more than 2 factors are there. 4 you can take more than, will get more than 2 factors. 1, 2 and 4, right? So, more than 2 factors. 4 you can see in 2 table as well. 4 table, definitely 4 is there. 4 ones are 4. But 2 table, you take 2 table, 2 twos are also 4, right? So, you can find more than 2 factors for 4. Okay? That's why we are telling 4 is a composite number. Right, children? 4 is a composite number. So, according to that, because many board questions are there regarding this composite number and the prime number. Okay. Now, I'll ask you one question. What is the smallest prime number? Can you give me the answer in the chat box? What is the lowest, that is smallest prime number? And what is the smallest composite number? All of you give me the answer. Q in the chat box. That is smallest composite number and smallest prime number. Tell me. Yeah, smallest prime number is 2 and smallest composite number is 4, right? Smallest 4 number is, yeah, correct. Very good. Very good. Yeah, 9 is a prime number. 9 is a prime number. I don't know who is this TTF. 9 is a prime number, definitely. Because 9, you take the factors of 9. we'll take the factors. Okay, all the factors will take it. 9. 3 3s are 9, and again you see 3 goes on 3, 1, right? So 3 3 1, right? So 3 3 1. That means you can see 9 in 3 table, 9 in the table of 3, right? 3 ones, 3 3s are 9, and you can find 9 in the 9s table also. Am I right? 9 ones are also 9. So you can find 9 in actually 3 table and 9 table. Both table you can see this 9. So you see that how many factors are there? 1 3 3 9 is also a factor, right? 1 3 3. So more than 2 factors are there. So 9 is a composite number. Okay, 9 is a composite number, no doubt at all. So what is actually this theorem says? 9 is a composite number. Correct. 9 is a composite number. So what about 1? Can you say about some? Actually, 1 is a special number. Can you say that in which category we can add this 1? Do you know that? Is it a prime number? Is it a prime number? Can you say, is it a prime number? 1 is a prime number? Is 1 a prime number? Is 1 a composite number? Is 1 a composite number? No. Yeah. Yeah, Pratish. Okay. So is 1 a composite number? Is 1 a prime number? What type of number is 1 actually? 1 is actually neither prime nor composite. Okay, so children used to say one thing. Always we'll ask what is that? What is the lowest prime number? Children will say that 1 or what is that? Actually, 1 is an odd number. Okay, but 1 is neither prime nor composite. You have to understand. You will not forget that one. Okay, and many questions regarding this that I will give you later. Okay, the many board questions are the what is the HCF of the least prime number and the least composite number? What is the LCM of LCM and HCF? We have to find out between the least composite. Many times it's repeated. I'll give you later. So what is the fundamental theorem of arithmetic? Can you say that now? Why we are studying here this one, this prime and composite? Because we have to learn about the fundamental theorem of arithmetic. Okay, only because of that fundamental theorem. What is the fundamental theorem of arithmetic? I'll take one simple number, children. One simple number. Yeah, correct. Pershad is correct. 1 is neither prime nor composite number. Yeah, correct. 0, Jason. 0 is actually 0 is an we can say that it's an even number and a whole number. Okay, but it's not a prime number. Okay, it's not a prime number. Yeah, yes, correct. Very good question. It's not a prime number. 0 is not a prime number. 0 we can include in this even number. Even number set we can include, because if any number is ending with a 0, you can say that 0, 2, 4, 6, 8. Okay, if any number that is units place, if in the units place you are getting number 0, 2, 4, is it everyone? Tell me. All of you are not getting. Is it? Can't hear. Oh my God. What happened? Everyone. Okay. You can't hear me? Am I audible? Okay. Okay. So is it clear what is the composite number and what is a prime number? Is it clear, everyone? Clear? May I go to the next composite now? This one, fundamental theorem of arithmetic. So what is the fundamental theorem of arithmetic? All the numbers in the sense, if we are taking, that is simple number I will take, a small number I will take, okay, 8. We don't want to go anywhere. A small number 8 you take. 8 you can write as 8 is equal to 2 into 2 into 2, right? 2 into, because 2 is a prime number, again a prime number, again a prime number. I'll take, wait children, wait. Yes, I'll show you here. It will be more clarity will be there. Okay. Now, actually, this is a question. First question I have taken from the exercise. Now, what is this one? What is that? Fundamental theorem of arithmetic. Okay, I'll clear that one. So, if 8 we can write as 2 into 2 into 2, right? 8. What are the prime? That is prime factorization of 8. You see, 2 goes on 8 4 times. Again 2 goes on for 2 times, right? Again if you want you can do till you gets 1. So 2, 1. Right children? So 8 is equal to 2 multiplied with the 2, multiplied with the 2. That is 8 we can write as product of primes. Okay? Product of primes. That is 2 into 2 into 2. That is equal to 2 cube. Okay? Can you see the board? 2 cube. So 8 can be written as the product of, that is 8 can be factorized as the product of primes. That is 2 is multiplied with the 2 is multiplied with the 2. That is 2 cube. Okay. So this is known as the fundamental theorem of arithmetic. Any sum, that is if you are getting any composite number, suppose composite number, I am taking another number, that is if it is some number, give me some number. Suppose it is 81. Okay, 81 is a composite number or prime number. 81 is a composite number because 9 nines are 81, right? More than 2 factors are there. So 81, we will see that how we can factorize this 81. Then 8 plus 1. First we will see 8 plus 1 is equal to 8 plus 1 is equal to 9, right? 9. So 9 is in the table of 3. So it is divisible by 3. So 81 is divisible by 3. First you want to check the divisibility test of 3. If it is an even number, 81 is not an even number. 81 is an odd number, right? Ending units place we are given 1. That means it is an odd number. Clear children? It is an odd number. So never it goes on the 2. You cannot take 2 because 2 is always divisible in the even numbers. That means if the ending numbers are, suppose it is 82, 84, 86, 88, 80, then this number must be divisible by 2. But here ending number is 1. Units place we are given 1, right? So it is an odd number. That odd number also you will have some confusion. What will be that? Which number will be divisible, right? Which number will be divisible? So you do one thing. First you add, if 2 is not divisible, you add these two numbers. 8 plus 1 is 9. 9 is in the table of 3, right? 9 is in the table of 3. So you can say that it is divisible by 3. So 3 goes on 8, 2 3s are 6. All of you do with me, take one paper and do it. 3 goes on 8, 2 3s are 6. 6 plus 2 is 8. So 3 goes on 21. It is 7 times, right? So 3, 9 3s are 27. Again 3 and 3, right? Again 3, right? So what is that? What are the factors? 81 can be written as 3 into 3 into 3 into 3, right? 81. Now see, all numbers are prime numbers. 3, 3, 3, 3. All numbers are prime numbers. So 81 can be factorized as the product of prime. Okay, which can be this one is unique one. It can be expressed in a unique way. 3 into 3 into 3 into 3. That is equal to 3 raised to the power 4. Okay, 3 raised to the power 4. So this is known as the fundamental theorem of arithmetic. Do you understand? Now we will take the first one, right? Now we'll take the first exercise. First one I'll take. May I take this, sir? So what is the first question? First question. Exercise 1 point, that is, it's not 1.2 children, this is actually 1.1. Okay, it's 1.1. It is actually 1.1. It's I have copied from the old version of the textbook. That's why it came as 1.2. Okay. Now what is here the question? Express each number as a product of its prime factors. Here you see, children. Here no, actually the important questions must be always, board will be repeating some certain questions only. They will not ask all the questions. See, I'll tell you. The one question many times they have repeated about the that second exercise. Prove that root 3 is irrational, root 5 is irrational, root 7 is irrational, that type of questions. Okay. Then next one is in that same exercise you can see that 5 plus root 3 is irrational. Then combination of the rational and irrational numbers are also irrational. That also we want to prove. That type of questions. Okay. Then in the first one, that is first exercise, they will ask find the HCF. If LCM and two numbers given, I'll teach you what is that. So in this question we will do only two questions. Okay, the remaining you try yourself because we will not get time to complete all these questions, right? So first one, express each number as a product of its prime. Shall we? May I take this exercise? May start this? Jason, what is the question? Ma'am, here we should express only in primes, or shall we express in composite also? No, Jason, we cannot express in composite number. We have to express only in prime numbers. Okay, because the question is, see, express each number as product of its prime factors. Prime factors. We have to express this in prime factors alone. So first one, which one will take? You tell me. May take one difficult question. 140 will be easy. Anyhow, I'll start from 140. 140. Okay, first question is 140. So here first question is 140. Now take the prime factorization. Yeah, 7429. Do you want to do the 7429? Yeah, I'll do it. First I'll start from 140. Because the simple to difficult, everybody want to understand this. So first I'll take a simple question, then I'll go to the difficult question. Okay, right? So first we'll take a simple question. Everybody want to understand what we have to do. Then we'll take the difficult question. Right? Right, Jaga? Now 140, right? So ending number is 0 here. Right? Ending number is 0. You can see that units place we are given 0. Now what will be the divisible number? What I said, if the units place is 0, 0, 2, 4, 6, 8, if these numbers are coming as a unit, yeah, so it is 142, yeah, Persia, correct, yeah, very good. 2 7s are 14, then 2 goes on 10, 14, then 2 goes on 0, 0 times, right? So ending number is 0. Again we can divisible with the 2. We can divide with the 2, right? We can divide with the 2. So 2 goes on 70. That is 35 into 2. 35 is multiplied with the 2. That is 70, right? Or you can do this method also. 2 goes on 7 3 times. 2 3s are 6, right? So 6 plus 1 is 7, right, children? So this one, if it is difficult for you, some children can't do it. 70, they cannot divide one step. So do one thing. 2 3s are 6. Again here 7 is there, right? 7. 10's place we are given 7. But 6 plus 1 is 7. That 1 you write here. Okay? Carry over that 1 here. Right, children? Here. So 2 goes on 10 5 times. Clear? 2 goes on 10 5 times. Now again ending number, units place 5 given, so 5. Again now you see that this will not be divisible by 3. You can check it. You can check it, children. 5 plus 3 is equal to 8, right? 5 and 3. Add 5 and 3. This way you can check your divisibility, because in this chapter, if you know which is the divisible number, you can save your time. That is how you can divide the numbers. You have to practice with the numbers. Okay, which number will be divisible? If the ending number is this one, what will be the divisible number? Or check the divisibility test. Yeah, how to check the divisibility test of 3? How we can check the divisibility test of 11? Everything is there. Different test is there, right? So you can check and just then only you will be getting that speed. Here the important thing is you want to get that, you have to maintain the speed. Then only you can complete your question paper within the time, right children? So 5 goes on 35 7 times. Why I said it is not divisible by 3? 5 plus 3 is 8. Can you see 8 in the 3 table? No, 8 is not in the 3's table, right? That's why we can take 3 will not be going on this 35. So 5 goes on 35 7 times, right? Again, if you want, that is actually waste of time only. If you are doing again 7 1, it is actually waste of time. 7 you got, stop there and write. Okay, write fast. That is 2 square into 5 into 7. This is the answer. 2 square into 5 into 7. Clear? Is clear? This way you can do this 140. Simple question. That's why I have taken this simple. Now which one? Now which one you can? 156. Come on, quickly do the answer and give me the do it and give me the answer in chat box. 156. Quick. Come on. 156. How you can do 156 and do it in the chat box? Just write the answer in chat box. What is the factor? What are the factors of 156? How you can divide 156? Yeah, I'm waiting. I have to get the answer now. Quick. 156 is equal to 2 square into 3 into 13. Yeah, all of you got it? Yeah. 156 2 square into 3 into 13. 3 into 13, is it 13, Jason? 156. Yeah, correct. Yeah, good. Correct. Okay, very good. Okay, very good. 2 into 3 into, okay. Now that I think you can do it. 156 easy. 3825. What about 3825? 156. I'll write the answer if anyone. Okay, those, because some children are starting, right? Some children will be struggling. So I'll tell you this one. 156. Same way, children. You can see this prime factorization. Same way, 156. Prime factorization 150. Ending number is 6. So 2 sevens are 14, right? 2 sevens are 14. Then 1 carrying, because 15. Here it is 15, right? 15. But 2 sevens are 14, right? 14 plus 1 is equal to 15. So 1 will be carrying. Here 1 is the remainder. So that 1 you can write here. Now the new number is 16. Okay. So 2 goes on 16 8 times. Then again 78. So ending number is 8. So 2. Right children? 2. So 2 goes on 78. 2 goes on 7 3 times. 3 times. Right? 3 2 3s are 6. 6 plus 1 is 7. Right? 6 plus 1. So 1 you can write here. 1. Now the number is 18. Can you able to follow me? 2 goes on 18. 2 9s are 18. Clear? 2 9s are 18. Any doubt? 2 9s are 18. Clear? 2 goes on 7 3 times. 2 3s are 6. 6 plus 1. Then 1 you can write here. 2 goes on 18 9 times. Again 39. That is 39 is an odd number, right? 39 is an odd number. 3 plus 9. Add 3 plus 9. 3 plus 9 is equal to 12, right? Divisibility test of 3 I am doing, right? 3 plus 9 is equal to 12. So 12 is in the table of 3, right? 12 is in the table of 3. So definitely this is divisible by 3. Some children, I know that some children can do without seeing the divisibility test. It's not a problem. But I am taking, that is those who cannot understand how to take this 3. That's why divisibility test we have to check. Divisibility test. That is 3 plus 9 is 12. So 12 is actually in the table of 3. So it is divisible by 3. 3 goes on 3 one time. Right children? Then 3 goes on 9 3 times. That's why 156 we are writing as 2 into 2, that is 2 square. Okay, twice 2 is repeating, 2 into 2 into 3 into 13, right? So this way we can write the prime factorization. Clear? Clear all of you? Now I'll take which one now? 3825. All of you got the answer? 3825. 3825. Okay, 3825 also do it and give me the, yes, 3 square into 5 square into 17. Okay, this way all of you do that. 3825. 3825, the third one. I will not get the time, children, so I thought 3825. Anyhow, I'll write the answer here. 3825 is equal to, what is the 3825? Again, you do the prime factorization. Prime factorization, that is 3825 is, what are the divisible numbers? First you can check. 5 plus 2 is 7, 7 plus 3 is, then 3, 8, 2, 5, right? 3, 8, 2, 5. Add all these numbers. 5 plus 2 is 7, 7 plus 3 is 10, 10 plus 8 is 18. 18. Okay. So if you are adding all these numbers, we are getting 18, right? 18. Now you see 18 is in the table of, 18 is in the table of where? 3. 18 is in the table of 3, right? So we can write, that is 3. It is divisible by 3. Okay, so 3 goes on 3 one time. What is this actually? 3 by 3. 3 is dividing with 3. Only that's what we are doing. 3 goes on 3 one time. 3 goes on 8. That is 3 2s are 6. 3 3s are 9. Right? So here 8. 8 is there. So 3 goes on 8. 2 times. 2 3s are 6. Then 6 plus 2, balance that number we can write here. Clear? Then there is 22. 3 goes on 22. 7 3s are 21. Are you getting the idea? 7 3s are 21. And 21 plus 1 is equal to 22. Here the number is 22. Right? 22. But 7 3s are 21. Right? 7 3s are 21. If you are taking 8, 8 3s are 24. We will not get 24 here. Here 22 alone. Right? So we will take 7. 7 3s are 21. 21 plus 1 is 22. Are you able to understand? I don't know whether you are following or not. 7, that is 7 3s are 21. Then again 21. Then what is the number? Carrying number is actually here 1. So 3 goes on 15. Actually, what is that? 5 times, right children? 1 2 1 2 7 5. Again you see this, which number is divisible here? Again you can add divisible. 5 is a divisible number, no doubt at all. 5 is divisible because ending number is 5. Before that you check 3, whether it is divisible by 3 or not. 2 plus 3, 2 plus 1 is 3. 3 plus 7 is 10. 10 plus 5 is 15. So divisible by 3. Okay, divisible by 3. So yeah, I'll do it. 7429. Don't worry, I'll do it. I'll do it. That is actually a complicated number. You have to know that the number. No other what is it? Hidden idea is there. You have to know about the numbers and we have to find out the number. I know that why people are asking about 7429, because such a difficult number will not get any prime factorization. So you want to understand that or tables of 13, 17, etc. Then only you can do that 7429. Okay children. So 3 goes on 12 here. I will continue this. 3 goes on 12 4 times. 3 goes on 7. 2 3s are 6. Then 1 time. Right? 2 3s are 6. 6 plus 1 is 7. So 1 you can write here. 3 goes on 15 5 times. Now 4 25. Again you add it. 4 plus 2 is 6. 6 plus 5 is 11. Okay. Can you see 3 in the table of 11? No. So it is not divisible by 3. So you take what number? Ending number is 5. 5. 5 goes on 42. 8 times. 8 5s are 40. Right? Okay. Now 8 5s are 40. Then 2. 5 goes on 25 5 times. Right? Again we can divisible by 5. 5 goes on 8 one time. Then 35. A reminder. 5 ones are 5. 6 7 8. Okay. So 35. So the carrying number is actually 35. The carry over here 3 will be writing here actually. 35. 5 goes on 35 7 times. Okay. Now 5, 3, 3, 5, 5, 17. Now you have to understand that 17 is a prime number. So no other divisible number is there. Okay. Except 1. No other number is there. So here except 1 means last you can divide with 17. Factors are 17 and 1. So 17, 1. So 3825 is equal to 3 square into 5 square into 17. Okay. I think most of you got this answer here. Right? Yeah. Very good. Yeah. Very good. Very good. Okay. Persia, Jason. Yeah, all of you got it. I cannot understand this Shobana Bhaskar. Anyhow, I don't know who is that. I can see only Shobana Bhaskar here. Okay. Now shall we? You are asking about the difficult question, right? What is the difficult question? Let me check. What is it? 7429, right? So 5005 is actually, what is the 5005? That is 5 into what is it? 5 into 7 into 11 into 13. Okay. Jason, what is the question? Ma'am, here if I directly go to the table of 5, then the answer will, no, it will not be no wrong answer. It will be correct only. But what I am telling is our prime number starting, we can do that, no problem. Because no, you have to complete your question paper within the time. Whatever your shortcut, you can do that. Okay. So it's not a problem for you. Now I'll take 7429. Okay. Now the fifth question. Okay. Fourth question, all of you do that. Fourth question is 500. I'm just writing the answer here. If anyone don't know the answer, 5 into 7 into 11 into 13, right? 11 into 13. This is the prime factorization of 5005. This is the fourth question. Okay. Now the fifth question. What is the fifth question here? 7429. Yeah, I'm getting the answer here. 7429. Okay, 7429. So I don't know. Someone is calling here. Wait. Okay. Now what is next one? 7429. Take that. Yes. So first one 7429. Now the number 74. Now no number will be divisible in this. Okay. Such a difficult number we are given. You just check it. You cannot divisible with the 7. Can you divisible with the 7? Can you divide with the 7? No. You cannot divide with the 3. One digit, that is the single digit, is not divisible in this number. You can see that 7429 by 3. 7 plus 4 is 11. 11 plus 2 is 13. 13 plus 9, that is 22, right? 22 is not in the table of 3. So it is not divisible by 3. 3 not divisible by 3. It's not divisible by 5. It's not divisible by 7. Okay. So the one number, it is divisible. That is first you can take 17, children. That is no other trick for you. No other trick. You want to know that. That is actually, I think this type of question will not be coming to a question paper, your board question paper. They will not give like this. Anyhow, if at all it is given, you have to understand about the numbers. It's all, no other shortcut. You have to know the table of 13, 7. It's actually very difficult. Nowadays no one will be knowing about this 17. But this question I'll tell you, 17, 74. How many times the 17 goes on 74? You tell me. 17, actually it is 4 times, right? 4 times. So 17 fours are 68. Then 74 minus 68. What will get? 74 minus 68. You will get here 8, 6, then 6, right? 6. So it is 62, right? 17 goes on 62. How many times? 17 threes are 17 threes are, yeah. So how many times here? It is 3 times, right? 3 times. Am I right? 17, right? 17 goes on 74 6. Am I right, children? 17 fours. 7 fours are 28. 2. 1 fours are 4. 4 plus 2 68. 74 minus 68 is 6. Then 6 will be carrying here. Right, sorry. 74, yeah. 6 will be carrying here. Then 62, 53, 51. The next one 4, 3. The next what will get here? 17. Do it and give me the answer. What will get, children? 17. It's a big number. I know that's very difficult. 17 6 are 17 4s are then 72. Then here it is 6 62. 17 3s are 51. Then it is what will be that 437, right? Then again here which number will be going? Which number? 437. Which number? 437. Is it 19? 19 will be going. No other number will be there. 19. Okay. So 19, that is 43. If it is difficult for you, do one thing, children. Can you see the board? Is it visible? Is it visible? Yeah. So 7429. Which number will be going? The next one 19437. So again it is 23 times. Then again 23 and 1. Okay. So no other shortcut for you. You don't think that there will be some shortcut we can do in that shortcut. No other shortcut. You want to know this. Just check it. If you are getting any new question and that too like this such a difficult question, you have to check it, children. No other shortcut. Okay. So 7429 is 17 into 19 into 23. I hope this type of questions will not be there in your question paper. I think so. But this question has repeated. 5005. It's repeated. This question actually what how much mark will be there? Can you say that how much mark? Find the prime factorization. Then it is actually 1 mark question. Nothing else. Okay. These are actually find in the using the fundamental theorem of arithmetic, only 1 mark question. So 17 into 19 into 23. Clear? Clear, children? Yeah, 1 mark question. That's all. Nothing else. 1 mark question. These are prime factorization. That is not even 2 marks. Nowadays 2 mark question are actually a little bit big. It's not only 1 mark. Yes, no doubt at all. So these are important. But important means 1 mark question. That is the 20 questions will be the in your question paper. 21 mark questions are there. Then out of that here 18 questions are multiple choice questions. And 2 questions are actually assertion and reason based question. Out of 18 questions this can be the what are the prime factorization, something like that. Okay. Now see, children, now this one. Is it clear? This one, fundamental theorem of arithmetic, and this one. May I go to the next one, next topic. Then we'll stop. The next class we'll do that. Is it next one? Okay. Shortcut to find a 4-digit number. A question is a prime or composite. 4-digit number question is a prime or composite. No such see. Yeah, your question I can understand that because this type 5005 is 749. These are actually 4-digit number. Only the thing is that if the ending number is 5, okay, ending number is 5. That is units place. If you are given 5, so it's 5 or 0. It's divisible by 5. No doubt at all, right? It's divisible by 5. That way you check and see. That's only we can do that. Check it. A divisibility test we can do up to 3. We can do the divisibility test. Hmm? All of you know that 3 is now I have shown that how to do the divisibility test. Add it or add all the numbers and the answer is in the table of 3. That is the one, check it, okay, whether it is divisible by 3 or not. Next one is the next prime number, we can say that 5. 5 means you know that 5 ending number is 5. Next one 7 also, no such, you want to check it, 7. Okay, but 11, what about the after that 5 7 11, there is a divisibility test. You know that what is the divisibility test for 11? It will be coming that next, it will be there, then I'll check, I'll do that. Okay, well, some questions are there, checking the divisibility of 11. Yeah, except one digit number. How to check, ma'am? Except one digit number. This is what we have to check, the ending units place, only that much. Units place, what is the number? See, 5, here 5 ending number, here 5 ending number, so divisibility 5. Here an ending number is 9, so definitely we'll go for the 3 table, right? Ending number is 9. Then again we will go 9. If ending number is 9, definitely we'll go the, what is that, 3 table and 7 table as well, right? 7 table as well. You see, 7 table, 7 sevens are 49, so 7 also can be there. That way you check. Okay, that's all. Everything is practice, children. When you are doing more practice, NCERT textbook you are given only this much, but you can take more questions and practice. You just play with the numbers, then you will get everything, all the ideas you will get. Then after seeing a number, you can say that, yeah, this number is divisible by this number, this one. That is what practice makes the man perfect. You got it? So always you practice it. That's what you want. Then only you can score. Because until and unless you are practicing, you will not get good mark. Because then only you can, what is that, speed up everything. Writing, you can increase your speed. Then concept will be clear for you. All the concept will be clear. So you can increase your speed. That's what. Okay. Now shall we go to the next one? No, we cannot study all the tables. You just learn about the 3 tables, 7, only that one, 15 table. Till the 15 table you learn. That's no need to learn it also. It will not be coming such a big number and confusing number. Okay, don't worry about it. Such a big number CBSE will not be giving. Numbers they won't give like that. Children will be in such a difficult situation, and they have to spend a lot of time for this, and it's a big number. CBSE will not give, but still you try. Okay, so may I go to the next topic? Clear? This topic is clear. May I go to the next topic? Next one is okay, till 8:30 we'll do it. Then I'll stop. Then whatever it is coming, I'll take in the next class. Okay, till 8:30 we'll go for it, because 7 o'clock we have started, right? Yes. So next topic is, now this is actually regarding the fundamental theorem of arithmetic. Okay, so next topic is here. What is the next topic? Here we have to learn about this one. Wait, children. That is a relationship between HCF, LCM and product of two numbers. Okay, relationship. Suppose here, what is that? It's find here the question exercise 1.2 directly we are given, but before that I'll tell you what is that relationship. HCF of here just HCF of two numbers, HCF into LCM is equal to product of two numbers. Product, that means if one number is A, another number is B, then HCF into LCM is equal to A into B. Okay, this relationship you have to learn. HCF into LCM is equal to A into B. I'll tell you what is this. Without understanding the concept, you cannot study this formula. I know that. Okay, actually what is the meaning of this relationship? Simply I'll take two numbers, children, 8 and I'll take 4 and 8. 4 and 8. Okay, take this 4 and 8. Now find everything. That is A is equal to 4 and B is equal to 8. Two numbers. Simply A is equal to 4 and B is equal to 8. Okay, 4 and 8. Now next you find out, so two numbers we are given. First number is A, that is 4, and second number is B, that is 8. Okay, now you take what is that actually product of A, no, first we'll take HCF of 4 and 8. Okay, 4 and 8, HCF of 4 and 8. What is HCF of 4 and 8? What is HCF of 4 and 8? What is a common number here? Actually, common number 4 and 8. 4 is equal to 4 ones are 4. 8 is equal to 4 twos are 8. Right? 4 twos are 8. So, what is the common number here? Common number is 4. Right? Common number is 4. This common number is known as the HCF. This is known as the HCF. Okay? So, HCF is equal to 4. HCF is equal to 4 because that is the highest common factor is 4 here. 4, 4. Right, children? Now, next one is we want to find out the LCM. What is the LCM of 4 and 8? LCM. That is, a common factor is 4. 4 into 1 into 2. That is equal to 4 twos are 8. 8 is the LCM. LCM is equal to 8. Okay. Now we see two numbers I have taken. First number is 4. Second number is 8. Right. And HCF of two number is 4. And LCM of two numbers is 8. Got it? Now we got A, B, LCM and HCF. Okay? 4. We are getting A, two numbers, LCM and HCF. Now, what is that? Now see the relationship. We'll see the relationship. What is the relationship here? LCM into HCF is equal to product of two numbers, A into B. Right? A into B. What is LCM? LCM is equal to 8. Right? What is the HCF? HCF is equal to 4. Okay? Now what is A? A. First number it is, what is the number? A is 4. First number is 4. And what is B? B is equal to 8. Now you see 8 4s are 32 and 4 8s are 32. Right? That means always if you are taking two numbers, this relationship will be maintaining always. This relationship will be there. That is HCF into LCM is equal to product of two numbers. Clear? Always this relationship will be there. From this any number you take any number. That is for example you take 5 and 10. 5 and 10 any number. That is first number is 5 and second number is 10. So LCM is equal to, what is LCM of 5 and 10? 10. Okay. LCM of 5 and HCF of 5 and 10, that is equal to 5. So LCM is 10 and HCF is 5. Right. Now multiply 10 5s are 50. Now these two numbers you multiply, 10 5s are 50. Right. So when you are multiplying two numbers, you will get the answer as LCM into HCF. Did you get the idea? This is what the relationship between LCM, HCF and product of two numbers. Okay. So, after this we can find out if two numbers are given. I'll tell you one thing. So, this formula also we have to generate here. We have to get one more formula, that is if LCM, can you? LCM into HCF is equal to product of two numbers. Product means multiplication, A into B. So, LCM is equal to product upon HCF. Got it? HCF. Suppose you want to find out HCF of two numbers. HCF is equal to product A into B upon LCM. Clear? Is it clear to you? So, LCM into HCF. Okay? Is it clear? This one is clear for you. A into B by LCM. So these are the two formulas. We have to use it for the LCM and HCF. Okay. Shall we see the question now? If you want, you can write it. That is, you write it here. What is this relationship? This is the main formula. One is the fundamental theorem of arithmetic. Another one is this formula. Okay. These are the two formulas. That is, here actually how many formulas are there? 3 formulas are there. There fundamental theorem of arithmetic, we are just finding the composite numbers, we are writing as the product of primes. Right? Now here this is the LCM and HCF. How will you find out LCM if you are given product of two numbers and HCF? How will you find out HCF if you are given product of two numbers and LCM? Clear? Shall we go to the question? This is the formula. Okay. Question here it is. Find the HCF and LCM of the following pair of integers and verify that LCM into HCF is equal to product of two numbers 26 and 91. First question is 26 and 91. Okay, I'll do it. 26 and 91. Okay. Shall we complete this one also? I cannot see. Are you here? If you are here, please give me yes. Yes in the chat box. Are you here? Yes. All of you give me yes in the chat box. Okay. Okay. Now the next one is what is the next one? HCF. Find the product of two numbers 26 and 91. 26 and 91. I'll take 26 and 91. So two numbers. A is equal to 26. You can write like this. Write with me one more time. You practice it. A is equal to 26. All of you take your pen and paper, rough paper. You do it. A is equal to 26 and B is equal to 830. Okay, 8 till 830. 830 will stop it. B is equal to what is that? B is equal to 91. Okay, B is equal to 91. Shall we stop till 8:15? Shall we take and stop? Okay. So 26 and 91. So first one we have to find out, that is we have to prove that HCF into LCM is equal to product of two numbers A into B. This is the relationship. Okay. HCF into LCM is equal to product of two numbers. First we will take 26. Two methods are there. You can do like this also. 26, 91. This method you can follow. That is 26 and 91. Both are divisible by 13. Okay. 26 divisible by 2, correct, but 91 is not divisible by 2. Okay, so this is actually 13. 13 sevens are 91, 13 twos are 26. So it is divisible by 13. 13 twos and 13 sevens. Okay, so what is HCF? Common factor, that is 13 is HCF. So HCF is equal to 13 and LCM. What is the LCM? LCM is equal to 13 into 2 into 7. 13 into 2 into 7. Tell me, what is there? 13 into 2 into 7? Multiply and give me the answer. 13 twos, 2 sevens are 14. 13 into 14, that is equal to, what will get? 13 into 14, that is equal to 13 14s. Multiply and give me 2 7, that is 182, right? 182. So LCM is equal to 182. Now how will you do this? After that, LCM is equal to 13, LCM is equal to 13 and HCF is equal to 182, right? This way find out HCF and LCM. Then you next one, what is, now tell me LHS, left hand side, LCM into HCF. What is LCM? LCM into HCF is equal to LCM into HCF is equal to left hand side, LHS is equal to 13 into 182. 13 into 182. Okay. Multiply and write the answer. Give me in the chat box. What is 13 into 182? Now next one is A into B. What is A? A is multiplied with the B. What is A? A is equal to 26. 26 into 91. Okay. LCM into HCF is equal to 13 into 182. A into B is equal to 26 into 91. Now we see what is 13 into 182. Give me in the chat box. What is that answer? 13 into, give me 2366, right? 2366. What is 26 into 91? That is also 2366. Now you see left hand side is equal to right hand side. That is LHS is equal to RHS. LHS is equal to RHS. LHS is equal to RHS. Hence verified. How will you write the answer? It is verification. We have to verify the result. That is hence verified. That means hence verified. Okay? Hence verified. Clear? This way we have to find out the relationship. Okay? Okay, I think 5 more minutes will take and we'll wind up. 5 more minutes. Clear? Now, what is the, do you want to say this one more time? 2366. Both side we are getting 2366. Okay, right? Now, next one. 5 more minutes. Now it is 8:10. Now I'll be taking till 8:15. Then I'll wind up. So next class I'll be taking for the next one. Now see this. And again, which one we can take? Tell me. Which one? Come on, give me. Shall you take 336 and 54? Third question. Okay. I think this one will take 336 and 54. We'll take this 336 and 54. Come on, do it with me, all of you. Come on, quick, do. 336 and 54. Is it third question? Yeah, third question. Okay, all of you do and show me. Give me the chat box. Third question. Third one is actually, what is the third question? I have kept a textbook here. Third question is 336 and what is it? Again, I want to see that. My God. 336 and 54. 336 and 54. Come on, do it and give me the answer first. Give me the answer. I'm waiting. 336. 336 and 54. So first we'll take 336. 336. Which one is easy for you? Together shall we take, or that is separate one? That is each one 336 separate and 54. 336 and 54. Let me see this. Okay. So ending number 6 and 4, right? 6 here, 6 here, 4. So both are divisible by 2, right? So 2. First you see 336 by 2. 336 by 2. 2 goes on 3 one time. Then 1 carrying. 2 goes on 13 6 times. Again 1 carrying, right? 8. Now here 2 goes on 54. 27 2s are 54. Right? Next one again 168 and 27. Is there any common factor in this 168 and 27? You check it. Any other common factor? You check the divisibility test of 3. 3. 8 is actually ending number. 168 is an even number. No doubt at all, even number, because the units place we are getting 8. Right? So even number. But 27 is not an even number. So there is a twist, right? 27, 7 is not an even number. Units place 7 given, so it's not an even number. So do one thing, check the divisibility test of 3. So 8 plus 6 is 14, 14 plus 1 is 15, right? So this sum is 15. Am I right, children? 15. Now 7 plus 2 is 9, right? 9. Now you do one thing, both are divisible by 3, no doubt, because 15 is in the table of 3, 9 is in the table of 3. So both are divisible by 3. This way you can check the divisibility test. Okay, don't write within that is, if you are getting 168 and 27, don't write that there is no other common factor. Common factor is there, 3. Okay, common factor is there. So 3 goes on 16 5 times. 5 3s are 15. 1 carrying. 3 goes are 18 6 times, right? So 3 goes on 27. Again it is 9 3s are 27. 9 times. Clear? 9 times. Now 56 and 9. Is there any common factor? 56 and 9? 56 and 9. No. 56 is an even number. 9 is an odd number. 3 will not be going on. 6 plus 5 is 11 and it is 9. So 3 will not be going. Do it. Are you doing with me? Do it. Okay, do. Take your pen and paper and do it. 56 and 9. So, no other common factor. So, you just count the common factor. 2 and 3. There is 2 and 3 are common factors. So, HCF. HCF is equal to 2 into 3. Clear? 2 into 3. 2 into 3. That is 6. Okay. Next one, LCM. LCM is equal to 2 into, that is 2 into 3 into, just multiply. 2 into, no other common factor. 2 into 3 into 56 into 9. Multiply this. No other, you don't want to do any other prime factorization. Stop there. Then multiply this. 2 into 3 into 56 into 9. That will be the LCM. What you are getting as LCM? Give me the answer. LCM, LCM. Quick. What is LCM? Oh, 3024. Okay. Done. Okay, Persia finished. Then, yeah, all of you finished. Okay, very good. Very good, children. 3024. Okay, HCF is equal to 6 and LCM is equal to 3024. Right, children? Now you multiply. Now, what is the relationship? What do you want to verify? HCF into LCM is equal to A into B. Right? A into B. What is the LCF? 6 into LCM is equal to 3024. Okay? Write the answer. What is it? 6 into 3024. What is A? A is equal to 336 into 54. Actually, should not write like this. This is wrong actually. Okay, we are not proving now. This one you should not write. It is a wrong step. You want to take separately. That is LCM and HCF. Because after getting only we can write it's verified. This one we have to verify this result. So what is HCF into LCM? HCF into LCM is equal to 6 into 3024. What is 3 into 6 into 3? I don't want to multiply anything. Everything I am getting in the chat box is very good. Very good. 3024 into 6 is 181. How much? 18144. Very good, children. 18144. Okay. Now next one, A into B. Product of two numbers. What is A into B? 3. What is A? A. The number itself. Don't get confused. What is A? What is B? Nothing. What is the question? Question two numbers. In the question we are given two numbers, A and B. Okay. So one number is 336. Another number is 54. That's all. 336 into 54. Same, I think it is 18144. Okay. 18144. Clear? 18144. That means LHS is equal to RHS. LHS. Therefore, you see LHS and RHS. Therefore, LHS is equal to RHS. Next one, hence verified. That's all. We have to verify the result. So, what do you want to write? Hence verified. Hence verified. Okay, that's all. So, may stop. 1 hour and 15 minutes. More than that, no one can study. Okay, continuous study is not good. Right? You will forget everything. So next class when I come, I will take the continuation, and only one question I will be taking, and important questions and difficult questions I will be giving more time. Okay. So shall we wind up? To next one you just see, and wait. I am going to stop sharing. Stop sharing. No, reset. Yeah. What is this? Oops. Okay. Now coming here. Okay. Okay. Then go and have your food. Is it raining? No. No, no, not raining. What about you? Raining? Okay, raining, then it will be very nice. Such a hot climate, right? Very heat. So it will be, we have to get a rain. That's what we want. Okay, it's raining. Okay, then bye. Happy to see you all, and very nice to thank you so much for being with me 1 hour and 15 minutes. Thank you so much. If there is any doubt, and you please give me in the chat box, if you just give me that, okay, I'll clear it. And next class also same way I'll be giving that. Root sums, I'll do it. I know that's a little bit difficult. Prove that it is irrational. I'll do it. Okay, I'll be coming like this and I'll do it next class. Okay, thank you. Bye. 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 Okay, bye, bye, bye.